It was requested that I do a couple more examples, so I'm going to do two more examples of solving linear equations where I need to do some fraction busting. So let's see. For this particular example, I have three denominators, and they all have x's in the denominator, so we got to worry about what's acceptable values for x. So I'm going to go for the easiest one first. We're going to look at that middle one. The x plus 3, we cannot have that equal to 0. So if we solve that, x cannot be 3. So that's for that middle piece right there. Now if we look at the other two denominators, they're the same. So we only need to do it once. So we're going to set x squared minus 9 not equal to 0. And that is a difference of squares. And what it's going to factor into is x minus 3 and x plus 3. And that cannot equal 0. So that means that both x cannot equal 3 and x cannot be negative 3. That's what's going to happen here. So x cannot equal plus or minus 3 would be the shorthand notation for that. Now we've actually factored the denominators x squared minus 9 and x squared minus 9. It is x minus 3, x plus 3. And notice that we also have that factor of x plus 3 there. So the LCM is just going to be x minus 3, x plus 3. Let me get rid of this red line stuff here. So our LCM is going to be x minus 3 and x plus 3. And now what we're going to do is we're going to clear the fractions, or we'll do fraction busting. And so I'm going to multiply each of these terms by x minus 3, x plus 3 over 1 in the equation here. And I'm going to go ahead and factor the x squared minus 9 and the x squared minus 9. That's also going to happen. So that's what's happening in this step here. Alright, so each term in this equation is going to be multiplied by the least common multiple. And then we'll barely have enough room to cram it in here. So that is a 3 there, an x minus 3, x plus 3. And then we can start canceling. So all the factors cancel out in the denominator. We got x minus 3, x plus 3, and all we're left with is just the x. On the second piece, the x plus 3's are going to cancel. And we have x minus 3 times the 4. The 4 is left over there. It doesn't matter if you put it in the front or back, it works out the same. The distributive property will work at the back or in the front. And then the x minus 3, x plus 3's cancel out. And so we have x plus the quantity x minus 3 times 4 equals 3. I'm going to go ahead and distribute that 4 through. So x plus 4x minus 12 equals 3. It's a regular equation, combine like terms. 5x minus 12 equals 3. Add 12 to both sides. 5x is equal to 15, and we're going to divide both sides by 5. And we get x is equal to 3. Now this is why we do that note at the beginning. We noted at the beginning that x couldn't be plus or minus 3. Well, we got an answer of x is 3. So if I try to substitute that in, I'm going to get the x squared minus 9 and the x squared minus 9's to be 0. And that's going to have me dividing by 0. And we can't do that. So we're going to say this one's no solution. We only got one answer, and it wasn't a good one. So you can cross it out and write no solution. So I'm going to do one more, and it's going to be similar to the one we did in class. I think it's just different numbers. So here's the problem, and we're going to go ahead and take both denominators, and we're going to set them not equal to 0, and go ahead and solve them for not equal to 0. And one of their problem numbers would be 7/10, so if we get an answer of 7/10, we'll say that's not good, and we'll solve the other one, and w cannot equal negative 7/5. The last example we actually did some factoring. This one we're not going to do some factoring because 10w minus 7 and 5w plus 7, that's these two denominators here. those are already factored. They don't have anything in common, so the LCM is just going to be the product of those two. So our LCM is just going to be the product of those two. And now we're going to go ahead and clear the fraction, so a fraction bust. So we're going to multiply both sides of this equation by the LCM. And then I'm going to put some parentheses around, sort of for decoration, on the first piece right here, just to help myself with the multiplication. And then I'm going to do the same thing with that other piece in the black ink there. I'm just going to put some parentheses there, just to kind of help remind myself that I'm doing multiplication. And now we're going to go ahead and clear out the like factors, so the 10w minus 7's drop out, and we have 5w plus 7 times 8w plus 5 left over. And then the 5w plus 7's drop out, and we're left with a 10w minus 7 and a 4w minus 3. And now we'll go ahead and FOIL. So FOIL only works for binomials, and it stands for the first times the first, the outside or the outer times the outer, or the outer, so just the outsides, and then the inner or inside, and then the last. So that's what these arrows are. I drew this black vertical line here just to kind of separate stuff out, try to make it a little bit clearer. So right here, what I'm doing is I'm just foiling out. The arrows are there just to kind of guide us for doing the foiling. So just multiplying that all out. And this is going to be similar to the one like we had in class, where you see we have 40w squared and 40w squared, and I've already started crossing one of them out, and I'm going to cross the other one out because I can subtract 40w squared from both sides, and the quadratic term, the squared term, is going to drop out, so it's going to change it into a linear. And then the next thing I'm doing is I'm combining my like terms on each side. So the like terms were the w, so 25w and 56w made the 81w, and the negative 30w and the minus 28w made the negative 58w. I want to get all the w's on the left and all the numbers on the right, so what I'm going to do is I'm going to add 58w to both sides, and then I'm going to subtract 35 from both sides. So that's what's going on in this next step. I think I didn't do a very good job of writing 58 over on the right here. So right there, should say 58. I think I do erase it to make it look, yeah, I did erase it to make it look more like a 58. Alright, and one more step to do. I didn't have room to write it, so we divide both sides by 139, and we get w is equal to negative 14 over 139. And that one's a good answer because the two answers we would not accept would be 7/10 and negative 7/10.